Every important machine on Earth is run by someone who is nowhere near it. Right now, over 14 million of them are sitting on the open internet, waiting for a login. Put a fresh one online, and the first attack arrives in 52 seconds. Nobody sends a person, they send a key, and the lock that key opens has one strange property. The most trusted security tool on the planet last counted itself in 2008. This is its real statistics page. Measured once, frozen ever since, and never run again. The most deployed security tool on Earth stopped keeping score 18 years ago. Nobody is keeping score. It just works. And all of it exists because in 1995, a thief robbed the wrong Finn. This is the story of the key to every machine. SSH, and this month it turns 31 years old. Rewind, 1995, Helsinki, the same city 4 years after a student there gave the world Linux. At the Helsinki University of Technology, someone plants a password sniffer on the network. It is patient, it watches every login, and it only needs the beginning of each one. A year earlier, the internet's own emergency team had warned it was happening everywhere. Because in 1995, the internet was a postcard. Telnet, Arlogin. FTP, you typed your password and it crossed the wire as plain text for anyone listening to read. The sniffer was found with thousands of usernames and passwords already in its database. One of the researchers who saw that database was a man named Tatu Ylönen. He did not file a report and move on. He spent 3 months building a lock. On July 10th, he emailed the internet's address authority and asked for one free port number. He picked 22. It sat empty between FTP and Telnet, the two things his program would replace. The next day, a pioneer of the early internet wrote back. One email, one day, and port 22 has been his ever since. On July 12, 1995, at 5:51 in the evening, he shipped it. Free, source code included, downloaded from Finnish servers for a reason we will get to. By the end of the year, it was running at thousands of sites in at least 50 countries. The world changed its front door locks in a single summer. But here is the part they do not teach you. Building this in America might have been a crime. In the United States, strong encryption was legally a munition, controlled for export like a missile. To prove how absurd that was, cryptographers printed the code on a t-shirt. 3 lines of code and a barcode, so the shirt itself was machine-readable software. Under the law, letting a foreigner even look at your chest was arguably exporting a weapon. Someone formally asked the government whether the shirt was a munition. The office never wrote back. The man who wrote a different encryption program, PGP, was investigated for 3 years. Then a graduate student sued, and a court finally said what should have been obvious. The government even proposed its own backdoor for everyone, a chip called Clipper. A researcher broke it in a year. It was dead by 1996. And through all of it, SSH just kept spreading, because it was written in Finland and served from Finnish computers. American law could restrict what left the country. It could not touch what came in from a Finnish student. Math escaped. Then SSH did what every good thing eventually does. It went commercial. The free version stopped. The license tightened. If you have seen our Linux film, you know exactly what happens next. In 1999, the team behind OpenBSD took the last free version and forked it, OpenSSH. There was one problem. The encryption code was still tangled in American patents. So a developer named Niels Provos drove to Canada and rewrote the code on Canadian soil, where the patents did not reach. A clean, free lock, one with a car and a border. 9 weeks later, it shipped with the operating system. Today, roughly 9 out of 10 SSH servers on the standard port run that free fork. The same law proven twice, the free recipe wins. So how does the lock actually work? Because what it does sounds impossible. You and a machine you have never met agree on a secret password out loud while the whole world listens, and the world learns nothing. The trick is 1976 math, and it is easiest to see as paint. You each start with the same public color. You each add a secret color and swap the mixtures in the open. Then you each add your secret again. You both reach the exact same final color. An eavesdropper cannot unmix paint. But mixing paint only hides the secret. It does not tell you who you are mixing with. That is the dangerous part. So the first time you connect, SSH shows you this, and almost nobody reads it. That fingerprint is the machine's identity. Type yes and you trust it forever. It is called trust on first use. The rulebook itself, written in 2006, called this a temporary fix until something better came along. 20 years later, nothing better came along. The leap of faith won because it was usable. Once you trust the machine, how does it trust you? Not with a password, with a pair of keys. One command makes them. The modern default is tiny and unbreakable. A public key you hand out to the whole world, and a private key that never, ever leaves your machine. One command copies the public one to the server. And now you log in with no password at all. The server sends a puzzle only your private key can sign. The secret never travels. Why does this matter? Because a password is a secret you send, and someone is always listening. Remember those fresh servers attacked in 52 seconds? This is what the attack looks like. Endless. On a single exposed server, thousands of guesses a day. 96% of them trying to log in as root. The most tried password on Earth still is 123456. A key ends that game forever. There is one more power hidden in SSH. It can carry anything. A database locked away on a distant server, reachable only by that server itself. One flag and it appears on your laptop. Or the reverse. Expose your laptop to the world, punching out from behind any firewall. This is how people fix things they are nowhere near. From a train, from a wedding, from the far side of the earth. But power cuts both ways. There is one feature you should almost never use. In 2019, one team forwarded their keys to a server an attacker had booby-trapped. It spread across their whole fleet. Their advice in their own words: never forward your agent, use a jump host instead. Before we get to the closest call, understand what this key now protects, and what happens when the old locks come back. In 2016, the enemy SSH was built to kill came back. Telnet, the plain text protocol from the postcard days. Hundreds of thousands of cameras and routers still spoke it, still using their factory passwords. A single attack turned them into a weapon. It took down Twitter, Netflix, and half the internet's biggest sites in one afternoon. 21 years after a Finn built the armored door, the world got slammed through the screen door it forgot to close. But where the armored door is used, it reaches almost anywhere, including straight up. School children have run their code on tiny computers aboard the International Space Station, uploaded over SSH, port 22 forwarded to the ground. The same 3 letters that reach a $5 server reach a machine moving at 28,000 kilometers an hour, 400 kilometers overhead. And that power is absolute. In 2017, an engineer at GitLab had 2 terminal windows open, one a broken copy, one the live database. Tired, he typed remove on the wrong one. He stopped with a few gigabytes left of 300. The danger of SSH is that every window looks the same. Which brings us to the closest call in the history of the internet. March 2024. A Microsoft engineer named Andres Freund is testing his own database software. He needs a quiet machine. He notices something tiny. Failed logins, the kind that should be instant, are burning strange amounts of processor time. A login that should take 0.3 of a second was taking 0.8. Half a second, most people never feel it. He pulled the thread. Buried inside a tiny compression tool that almost every Linux computer quietly depends on was a backdoor. And it had been planted patiently over 2 years. But the target was never really the code. It was a person. The tool was maintained by one exhausted volunteer for free for years. And in 2022, the pressure started. Strangers appeared on the mailing list, accounts never seen anywhere else on the internet before or since. They pushed, month after month, get a new maintainer, you are choking your own project. And then the maintainer answered, honestly, in public. 6 days later, they pushed harder. Then someone new offered to help, kind, patient, always available. And the tired man, grateful, gave them the keys. He signed off with a smiley face. That smiley is the saddest thing in this entire story. 2 years later, the backdoor shipped. Whoever they were days from every server on Earth. It was already flowing into the next versions of the biggest Linux systems. The next big Ubuntu beta was 6 days away when Andres Freund pressed send on this email. Here it is, the real thing. Luckily, one word in a plain text email at 8:51 in the morning. That word is the only reason you are safe. He later said it plainly. It really required a lot of coincidences. And here is the part that closes a circle. The engineer who saved every Linux machine on Earth works for Microsoft. If you saw our Linux film, you remember how it ended. Microsoft, once the enemy, saying it loved Linux. This is that promise kept. So who guards the locks of the world? It turns out mostly unpaid volunteers. One of them, exhausted, almost lost everything for all of us. When it was over, Germany's own open source fund published this response and answered a global crisis by linking a webcomic. A cartoon about all modern infrastructure balanced on one tiny project, maintained by one person somewhere, for years, for free. And it was not a one-time thing. 3 weeks after XZ, another foundation caught the exact same trick, aimed at a different project. The lock held, but only because a few people this time happened to be paying attention. And the lock is already being rebuilt for an enemy that does not exist yet. Somewhere adversaries are recording encrypted traffic they cannot read today, storing it, waiting. Because a quantum computer, when it arrives, might crack today's math. So SSH already switched to math it cannot break. The newest version will now warn you, mid-login, if the machine you are reaching is too old to defend itself. The lock a student built in a rage in 1995 is now defending you against a machine that has not been born. So here is your homework. 3 commands and you will never type a server password again. 1. Make your keys. 2. Send the public one to your server. 3. Login, no password, just you. And when you are ready, the master move. Turn passwords off completely. The robots can knock 52 seconds after you boot. Now there is nothing to guess. 8 ideas, that is the whole story. The postcard internet, the lock built from a robbery, math that escaped a government. The free fork, that one, the paint that hides a secret, the 2 keys, the tunnel, and the curiosity that saved us all. You will never see the machines that hold your money, your photos, your country. The only reason you can trust them is that in 1995, a thief picked the wrong fin. And that student's name is still there. In the manual on nearly every server alive today, one line has never changed. Espoo, Finland. the exact campus where that sniffer was caught 31 years ago and still shipping today. New story every week. Subscribe if you want the next one. This is Cathanium. Every idea in tech has a story.